Okay, so let's start this. So they're saying write each of the set. What is the question? Write each of the set B is equals to chan to this expression here in roster form. Okay, so they're saying write this set here in roster form. So you simply have to just understand what they are doing here. So the set B is a set given, it's a set of x such that x is equals to n to the power 4 minus 1. Okay, so the value of x for this set is x is equals to n to the power 4 minus 1, right? So we'll be using this this equation here to find the values of x, right? And then here they're setting that x is a natural number. So I hope you remember what natural numbers are, starting from 1, 2, 3, 4 until infinite. Okay, so counting numbers are what we call as natural numbers. So they're saying n is a natural number, and then this n is greater than 4. Okay, so it means in this set we're going to start our n at 5, and then we'll go at 6, 7, 8, just like that until infinity, right? So we can just find maybe 3 terms there, and then we put 3 dots there, dot, to indicate that it's still going like that. Okay, so our first x will be when this n is equals to 5. So it will be x is equals to 5 to the power 4 minus 1. So what is 5 to the power 4? Okay, so 5 to the power 4 is 625. And then you minus 1 is going to give you 624. So this will be our first value of x. So if I can write the b here in roster form, I would say, but my first value is just 624 there. And then I'll say comma. Then let's find our x when this n is 5, right? Okay. So let's solve it from right here. Okay, so now our n is 6. So it will be 6 to the power 4 minus 1. So what is 6 to the power 4? Okay, that's telling me 1, 2, 9, 6. And then we say this value here minus 1. We are going to get 1, 2, 9, 5, right? So this will be my second member in this set B, 5, comma. And then my third member, I'll use 7 there. I can use 8, 9, just like that. Okay, but I'll just end on 7. I'll just write 3 terms there to be enough. Okay, so always make sure you write 3 terms or more. Okay, so our third term will be when this n is equals to what? To 7. So 7 to the power 4 minus 1 is equals to, okay, it's giving me 2401 minus 1, which will just be 2400 like that. So this will be the third term in this set. So 2400, and then comma, I'll say do, until forever like that. Okay, so this is the set in roster form. Okay, so in roster form, they are just simply telling you to list the element of that set, and they have given you conditions there, right? Okay, so is that clear, guys? Is it okay? I can proceed? Or you have questions? Okay, that's okay. Okay, let's go to B. To B now, we are moving from the roster form to the set builder form. Okay, so go to my board here so that I show it clearly. Okay, so we are moving from the roster form to the set builder form. So I've been given the set A is equals to, and then they're saying 1 over 5, comma, 1 over 3, comma, 3 over 7, comma, 1 over 2. Okay. The transitive rule, it means that if I get the first one here, I'll say 1 over 5. Okay. I'll write it as 1 over 5, just like that. And then for the next one there, I'll multiply it by 2. Okay. I'll multiply both the top part and the lower part by 2. So from 1 over 3, it will become 2 over 6, right? Okay. And then the third one there, it will be, yeah, I think the transitive rule works. 3 over 7, 3 over 7, you leave it like that. And then the fourth one, again, you multiply it by 2. So 1 over 2 is going to become what? Okay. So in what other way can we write 1 over 2? Okay. In what other way can we write 1 over 2? We can write it as 2 over 4. Or if we want, we can write it as 4 over 8. Okay. So that's what the transitive rule means. Okay. So I'm going to get this guy here because it makes a sequence here. You can see that on the top part there, let me show you. Let me use the black card, different card. On the top part there, you have 1, and then you come to 2, you come to 3, and then here you come to 4, right? So that's a sequence there, meaning the transitive rule is working. And then down there you have a 5, there you have a 6, and then there you have 7, and then there you have 8. You can see that the transitive rule is also working there. You have numbers in order like that, right? Okay, so it means our pairs, which are these pairs here, can also be written as 1 over 5, 2 over 6, 3 over 7, and then here 4 over 8. Okay, and for this sequence here, what is the set builder notation? We can see that whatever value is on top there, okay, they're just adding 4. They're just adding 4. So to get this 1 over 5, they're saying 1 over 1 plus 4, which will be 1 over 5, right? And then here, they're also saying 2 over 2 plus 4. And then on the third one, they're saying 3 over 3 plus 4, right? And then on the fourth one, they're saying 4 over 4 plus 4. You can say that this one works, right? Okay, so meaning if we take these numbers on top here as our natural numbers, okay? So we say whatever number is on top there, we'll represent it as n. So the formula will be our x will be equals to n on top, and then down there, they're just saying n plus 4. So this will be our set builder notation there. You can see that this value here will work for all of these here that we found. Okay, and then you write it in set builder notation. Okay, write it in set builder notation, because this sequence here is terminating at 4. It means your n has to be less than or equal to 4, right? So you're going to say my a is therefore equals to set x is such that my x is equals to my n over n plus 4. And then this n is a member of natural numbers. That's the first condition. And then the n should be greater than, less than or equal to 4, because the n's there are ending at 4. Okay, so this should be less than or equal to 4 like that. And then you close the bracket. So this here will be our notation, right? Yeah, so this will be our set builder notation. So use that one here, you're going to be finding all these values here. And when you reduce this and you reduce that, you're going to get the same roster form that we had at the beginning. Right. Okay. So use the transitive rule here. Okay, then let's go to B. What is the question now? Okay, so B, they're saying prove that the root of C is irrational. Okay, so how do you prove that C is irrational? So you do it by contradiction, right? You do it by contradiction. You're going to say, okay, you're going to say suppose. Okay, so you're going to say suppose root of 6 is rational. Okay, so you're going to suppose the opposite. They're saying prove that it is irrational, but you in your proof, you're going to suppose that it is rational, right? So suppose this root of 6 is rational, like that. Okay, so if this number is rational, then there exists, okay, there exist two integers, a and b, okay, such that the b is not equals to 0, and then the a over b is in lowest common terms, right? Okay, so meaning we're going to equate this root of 6 to a over b like that. And then we are going to square both sides. So if you square this side, the root is going to go. You're just going to remember 6 is equals to the square root of a over the square root of b, right? That's what we're going to do mainly. And from here, we can see that we can multiply here. Cross multiply, it means our a squared will just be equals to 6b squared. Okay, just be equals to 6b squared there. Meaning what? Okay, meaning what? Meaning that okay, so meaning that this 6 here is a factor of the a squared, right? Okay, so this 6 here will be a factor of this a squared. Why? Because I can get this number by multiplying 6 by this b squared. So I'm going to say, therefore, 6, okay, is a factor of a squared. Okay, so 6 is a factor of a squared. Then it means that it means that 6 will also be a factor of just the a when you remove the square. Okay, so this is what it means. And then I'm going to take an arbitrary element. Let me call it, let me say C, okay? Let me say C. So I'm going to say C is equals to, I'm going to say a squared is equals to what? Let me say a squared is equals to 2C, okay? So I'm going to say that a squared be equals to, not 2C, I mean 6C like that, because we said this 6 is a factor of this a squared, right? Okay, so meaning wherever there's a squared here, I'm going to put this 6 squared. Okay, so 6C, I put it where the a squared there is, it should be equals to 6b squared. Okay, so here we're also trying to find that this guy here is a factor of the 6. So here when I multiply to be 36, c squared is equals to 6b squared like that. Then I divide by 6, even there I divide by 6. So this will be 6c squared is equals to b squared. Okay, so this point where we've reached is the same point like we had here. Okay, we had a squared here and then 6b squared. And then here we have b squared and then 6c squared. Okay, so this means that 6 is a factor of the c squared, right? So if it's a factor of the c squared, we also know that 6 is a factor of the c. Factor of the c here. Okay. Okay, so from this, okay, why was I writing c here? I'm supposed to write b here and then here b. Okay, so 6 is a factor of b squared because I'm multiplying 6 by c squared to get this b squared, right? It also means that 6 is a factor of b. So now by contradiction, we can see that 6 is a factor of b here, and then even here, the 6 is a factor of a, okay? So both a and b have a factor of 6. So 6 is a factor of both a and b, okay? But remember, our assumption was that a and b are in the lowest terms. They can't have a factor, right? Okay, so this is a contradiction that we are finding here, that 6 is a factor of a and b, right? Okay. And then you're going to say, hence, by contradiction. Okay, so some things in math are useless. What is this? Such proof by contradiction. Anyway, so hence, by contradiction, we say that the root of 6 is irrational. You can see that it doesn't even make sense, right? But that's how you do it. Okay, so the root of 6 there is irrational because of this contradiction here that we found there. Okay, so that's how you go about it. And then where's the other question? Okay, the other question now is set T is given by that, set S is given by that, then set R is given by that. And then they are saying find T, find the Cartesian product of T and this S intersection R. So we can find S intersection R here. So S intersection R is equals to what? So we are getting elements that are both in S and R. We can see that the 2 is there and the 4 is there, right? Okay, so this is our S intersection R, and then our T is just what? It's just 1, 2, 3. And then they're asking us to find T multiplied by S intersection R. So this is equals to what? So you're just going to get the ordered pairs here, right? Because this is a Cartesian product. So you're going to get 1 with everything here, 2 with everything, 3 with everything. So 1 will go with the 2 there. This will be our first pair. Our second pair will be 1 with the 4. Okay. Our third pair will be 2 with the 2. And then 2 with the 4. And then 3 with the 2. Okay. And then 3 with the 4. So that will be our Cartesian product for that set there. Okay. So that's how you find the Cartesian there. Okay, let's find the last question there. They're saying let the universal set be an interval from -4 to 12. Okay, and then A is from -2 to 7, and then B is from 5 to 10, and then C is from 2 to 8. Okay, and then they're saying find A intersection B union C and show your answer on the number line. Okay, so that's what we are going to do there. Let's go on my board here. Saying the universal set is equals to closed interval, okay, from -4 to 12. And then A was what? -2, I think, to 7. Okay. And then our B was 5 to 10. And then what was our C? Our C was, I've forgotten, let me check. Okay, our C was closed interval 2 to 8. Okay, closed interval, then you have 2 to 8 like that. Okay, so this is what we have. And then we are being told to find A intersection B. And then C. Okay, so this is what we have here. So how are we going to find this? We're just going to draw a number line, right? So if I draw my number line like that, so the universal set starts from -4 all the way up to 12. So I'm going to write that as my universal set, okay? That point is included, that point is included. And then I know that somewhere here, I'm going to have a 0 like that, okay? So let's plot the point A in red. The point A starts from -2, which is included, to 7, which is not included. Okay, so -2 can be somewhere there. And then my 7 can be somewhere there. So I'm starting from -2 here, which is included. So I'm going to shade this circle like that, because there it's a closed bracket. And then I'm going to go all the way up to where? To 7 open circle, because I have that bracket. And then this is my A, so I'm going to label it as my A. Then let's plot my B in, let's say blue. No. Let's use yellow there. Okay, so let's plot our B now. Our B starts from 5 all the way to 10. So 5 can be somewhere there, and then our 10 is there. Okay, this is a bad card. It means black. So 5 starts from there, and then our 10 is there. Okay, so 5, none of these are included. So I'm going to have an open circle there, and then an open circle there. So this is my B. And then now let's plot my C, which is a closed circle from and closed interval from 2 all the way up to 8. Okay, from 2 all the way up to 8. So 2 can be somewhere there, and then our 8, we know it's somewhere in between these two there. So it means my C will start from here, which is included at the 2, all the way up to 8, which is also included, right? So that will be our C. So my first thing there is to find the A intersection B, this guy here. So what is your A intersection B there? I'm going to shade. Okay, so A intersection B, you go where these two lines meet. So this is my A, and then that is my B. So it means my A intersection B, it is within this range, right, guys? Okay, so my A intersection B is from 5 to 7, but the 5 is not included and the 7 is not included. Okay, and then from there now they're saying I unionize this A intersection B with the C, right? With this C here. So we know that C is just getting everything. Okay, so we're going to get everything in C and everything in the A intersection B. Okay, so let me shade this. Let me say orange. Okay, so it means I'm going to shade starting from where C is there, all the way to where it's ending there. Okay, so you can see that the union there will start from 2 all the way up to 8, right? So A intersection B in brackets, and then union C will just be equals to the closed interval from 2 all the way up to 8. Okay, so that will be our union, this one here. You can see it there on the graph. Let me zoom out a bit. Yeah, you can see it on the graph there, where we have shaded with orange there. That's the interval. Okay, so we are done. I don't know if anyone has a question. Anyone has questions? Okay, so have a blessed night, guys, and continue revising for this for your exams.